The RAM of every element is accurately recorded in the periodic table. Using these values, the RMM or RFM of a substance can be calculated. Once the RMM or RFM is known, the molar mass of the substance can be deduced. This is done by simple proportion, where given mass is divided by molar mass to give equivalent moles, and given moles is multiplied by molar mass to give equivalent mass. For example, how many moles are present in 10.6 grams of sodium carbonate? Relative atomic masses. Sodium equals 23. Carbon equals 12. Oxygen equals 16. The RFM of sodium carbonate is equal to 23 times 2 plus 12 plus 16 times 3 is equal to 106 AMU. Therefore, 1 mole of sodium carbonate has a mass of 106 grams. The number of moles equals given mass G divided by mass of 1 mole, gram per mole, is equal to 10.6 grams divided by 106 grams per mole. Example 2. What is the mass of 0.2 moles of calcium carbonate? Relative atomic masses. Carbon equals 12. Oxygen equals 16. Calcium equals 40. First, we calculate the RFM of calcium carbonate. Is equal to 40 plus 12 plus 3 times 16 is equal to 100. Mass G is equal to the number of moles times the mass of 1 mole or molar mass, which is equal to 0.2 mole times 100 grams per mole equals 20 grams. Therefore, 0.2 mole of calcium carbonate has a mass of 20 grams. The number of individual entities or particles, atoms, molecules, or ions can also be calculated from the RAM and RFM. Earlier, we said that 1 mole of a substance is the amount of that substance that contains the same number of atoms as the carbon-12 atom. This is Avogadro's number, 6.02 times 10 to the 23 atoms. It follows that 1 mole of any substance contains this number of particles, be it atoms, molecules, or ions. In simple terms, if the number of particles or individual entities is known, then the number of moles of the same substances can be found, and vice versa. For example, how many atoms are present in 56 grams of aluminium metal? For a question like this, the first thing to do is to state that which we already know. The molar mass of aluminium is 27 grams per mole. 27 grams of aluminium metal contains 6.02 times 10 to the 23 aluminium atoms. Therefore, 56 grams of aluminium metal contain 56 grams times 6.02 times 10 to the 23 atoms, which is equal to 1.24 times 10 to the 24 atoms. Example 2. How many moles of aluminium are comprised of 1.24 times 10 to the 24 atoms? Again, we put in the information we know. 6.02 times 10 to the 23 atoms are contained in 1 mole of aluminium. Therefore, 1.24 times 10 to the 24 atoms of aluminium contains 2.06 moles. The same principle applies if we were to calculate the number of molecules in a given mass of a gas, or the number of moles contained in the given number of molecules of the gas. That concludes the first part of our lesson on mole concept. Join us again for part 2.